Hi, I'm Karsten Arnbjerg-Nielsen. I'm here to talk about cities and how they're impacted with climate change and how we can deal with that. First of all, what we have seen both in Denmark but also internationally is a huge increase in extreme precipitation over the last decades. It has led to rather dramatic pictures, both in Denmark and internationally, and we have spent quite a time on doing research on what is the cause and what can we expect in the future. This is a picture that summarizes what we have done so far. We have seen a quite dramatic increase over the past 40 years, leading to the changes in flood risk that we have seen primarily. When we look into the future, we use climate models to project the future. The black one here is actually assuming that we have a 2-degree scenario, and under the 2-degree scenario, we will expect not more than what we actually see now. If they do not reach an agreement in Paris, we will see actually much more extreme precipitation in the future. The red one here is actually a 6-degree scenario, saying what is the worst that can happen on a business as usual scenario. Over the next 100 years, we will continue to emit as we have done historically. That scenario means that we will have probably somewhere between 25 and 50% of all income in Copenhagen taxes will be spent on repair costs in Copenhagen. So even though it's just numbers on a chart, it will have quite significant impacts into what everyday life will be like for people from Copenhagen. Now we're moving to an international study here saying somewhere in the world, climate change is not the only driver, it may not even be the biggest one. Here we see population growth from Australia. Most of this will happen in cities. And we see that just the amount of people living in the city will change as much as the precipitation. Therefore, these people need houses, and therefore there will be a huge impact also because of this population growth. So there are many drivers, and we need to deal with them, all of them, in order to make the cities cope with extreme weather. What I typically do is research on water infrastructure. Here's a picture of a sewer system and of a wastewater treatment plant. If we look at those and only those two, we need to project just extreme precipitation, sea level rise, and then we can define suitable adaptation options. However, it may not be the right problem level to solve the problem with cities and climate change. If we also go to the city layout, all of a sudden we can see how industry comes in. What about natural heritage? What about where do we actually accept floods to occur? What happens with the city layout? Where do we have roads, pathways, parks, etc.? All of a sudden we have much more options to look for. And this is actually where we can start to make systematic risk assessments, saying where should floods be allowed to occur? Because now it's not just the infrastructure, but the entire city that we can use as a playground. Of course, for most people, cities are not really about infrastructure and layout. It's about function. Where do people live? Where do they have a good park? Do they have good concerts? Or do they have noise? Do they walk with a dog? Do they mainly see dog poo? All of these things are really what people care about. If we go there and recognize that that is also a need, then we also need to take into account what is the personal preference of people, what are their willingness to change, what is the role of the individual versus the role of society. Those things come into play and are inherent things that we need to take into account when we deal with cities. Of course, there are the global drivers that the cities also cannot impact themselves. Climate change, health, the way we deal with globalization. And the key drivers here, I put them, there are many, but equity, health and water for sure are 3 key drivers that any city must take into account in how they develop. We have tried together with, we have tried to build a model of the entire city. It requires a huge amount of data, and we tend to call it an integranster because it integrates everything and it's not really just a model, it's a monster, so therefore an integranster. Over here we have all the societal processes, what alliances are built in political and social sciences. This is where the city develops. So where do people want to live? Where do they want to work? How do they move around in the city? Where do we develop city? Where do we see cities that shrink because nobody wants to live there anymore? And then we see my little pet here, the water infrastructure, is really a very small part of what we call a biophysical module, where we measure and optimize typically as engineers. Into this huge intergrunster, we built what we call flood risk assessments, trying to take into account, does it matter for people where the flood risk is high, where the flood risk is low? Does it matter for people where it's flooded? For me, it's easy to plan where should the floods go, but perhaps in this huge model here, it may not be that important. But it's a research hypothesis that we're studying currently. We use a model for things like this. This is an Australian catchment where we have modeled and simulated and calibrated from 1963 to 2010. This is how the city both has developed and what the model expects that the city should develop. What we see is a tendency for filling, which means that we tend to use more and more space for houses, roads, and less for parks. We call it densification, and it's good for some things and bad for other things. One thing is that it leaves less space for water, which is fairly bad. When we make projections into the future, we know that it's going to be densifying, but perhaps we can influence how it is densifying. Can we try to take flood risk into account? So we try to make different scenarios, one where we are negligible or ignore flood risk, and one where we say actually we think that flood risk is very important and we need to take that into account in all the decisions that are made, allowing people to expand houses only where there's no or little flood risk, and in other areas there should simply be green space. When we look at the results, the black ones are the historic, how the city looked like when it was designed. We see there's a very low flood risk, or both in terms of flooded buildings and also flooded roads. So they're not flooded very often. When we look at the red one, that's how it looks today. Still, the increase is there, but it's fairly marginal. If we continue to ignore flood risk in our city development, we have spent all the spaces where we can easily use the green space for city development, and therefore the increase over time will be quite dramatic if we continue to ignore flood risk. On the other hand, if we incorporate flood risk systematically into how we deal with city development, then we can actually get a city with the same economic growth, same overall indicators, but the flood risk improves substantially. What I've been talking about here is how cities should cope with flood risk. I take the same picture as before. This is how we see, and we can make that good or bad. No doubt, cities are threatened. Cities are presently vulnerable. They are all there lying close to the coast. They're all vulnerable to precipitation. And this will continue. So it will be worse and worse if we do not take flood risk into account. On the other side, I think also it's quite clear that we can produce cities that are resilient, where we use water in a better way, where we take into account both the water infrastructure, but also how people think and how they want to live. And I think by that way, we are actually capable of making a city that is resilient and where we use water in a much better way than what we've done previously. So I hope that you will share this vision with me in trying to make these cities come true. So thanks for now.